In this lesson, we'll be covering navigating around the code, refactoring methods and classes, adding new classes. Okay, so here we are in the maze run project. Let's open up the main.cpp file. The first thing we can do when we're actually working on source code is remove all the distractions around us by double-clicking the tab of the file name. This maximizes the editor window, which is really nice when you're working on a more complex piece of code and you need as much screen real estate as possible. You can return it to its usual size by double-clicking again. You can also use the keyboard shortcut Ctrl-M to toggle the editor window to full size and back again. Now, I have a few favourite keyboard shortcuts that I use all the time, and the first of these is F3. So in the editor, if you press F3 over a piece of code, it will automatically open the declaration for you. It even works for headers and library calls, so it's a really easy way to find the code you want to look at without having to manually search for it. Here, I'll press F3 over the addGem function, and you can see it takes me straight into the declaration of the addGem method in the maze.cpp file. If I press F3 again on the gem class creation call, it takes me to the constructor for that class in the gem.cpp file. Now, if you've pressed F3 and want to quickly return to where you were before, you can use Ctrl F6 to open the previous file you were looking at in the editor. So here it returns me to maze.cpp, which is where I was just a second ago. Ctrl F6 pressed once will take you to the last file you looked at, but if you hold down Ctrl and press F6 again, it will toggle through the list of open files. You can see the box pop up here that shows me which files are available. Use Ctrl Shift F6 to navigate up the list, and Ctrl F6 to navigate down the list. You might be wondering why on earth I'm talking about all this file navigation. As soon as you start working on a project with more than a couple of files in it, it will become apparent. It saves you so much mouse movement and clicking. Truly, learning these shortcuts will make your whole experience of using the editor better. So let's Ctrl F6 back to main.cpp because that's where I want to be right now. Let's move down the source file a little bit and move our mouse cursor over the setup call. When you do this, Eclipse pops up a box that shows the declaration without changing the file you're looking at. So this is an even less labour-intensive way of seeing what a function call does. If you're mostly using the keyboard and not the mouse, you can force this box to appear by pressing F2. So it's F3 to go to the declaration and F2 to view the declaration in a handy pop-up box. Okay, let's press F3. Here we are in the maze class at the setup function. But now we want to know what this maze class actually looks like. So here comes another of my most favourite keyboard shortcuts in the editor, Control Tab. Control Tab toggles you between the header and the CPP file of any class that you're looking at. The day I discovered this, I was so happy. In C++, a language that deals with classes right from the outset, this is a wonderful thing, especially when you're editing and adding code in classes. Okay, so we can see header, CPP, header, CPP. It's just brilliant. Right, enough of that for now. We'll do some editing and get a feel for using Eclipse. You can make these changes along with me or follow the checklist for this section in your own time. The checklist covers all of the changes that I make. Remember that I have provided two versions of the source code, the original and the edited version, so even if you make a mistake somewhere, you can still access both versions of the code or start over again. I've been looking at my code and I've decided that this done method in the maze class is not particularly descriptive. I want to change it to something more sensible. Refactoring method names in Eclipse is really simple and completely automatic. One change and everything in your project will be updated accordingly. If we right click on the method name we want to change, and you can do this anywhere, it doesn't have to be in the header file, and select refactor rename, we get this little box asking for the new name. Let's call it cleanup because that's what it's doing. Enter the new name and press return. If we build the project now, just to check everything is still compilable, you can see it builds with no errors. Eclipse has changed the name of the method for us in all the places that were required. If we Control Tab to the CPP file, you can see the declaration is now maze cleanup. This function must be called somewhere else in the code, so again, we can check the name change with another handy navigation tool in Eclipse that finds code for you. If you right-click and select References Project, a search window pops up to the right here that shows where the function is used. In this program, it's only called in main.cpp, and you can see it's using the new name cleanup. Okay. Next, we're going to rename an entire class. I have a pos class in my project, but I think the name coord would be more descriptive because it's an object that holds an x and a y coordinate. This time we'll rename it from the Project Explorer. You can do it from the code just like we did before, but Eclipse is really flexible in renaming and will follow your instructions no matter where you select your method or class name. So in the Explorer, we'll expand the pos.h file and you can see an outline of the code underneath. This green C icon means a class, and if we expand that, you can see the class members and methods underneath too. Right-click the class name and select Refactor Rename. This time we get a pop-up box with some extra options. I'm going to leave these exactly as they are. You can opt to change the name in comments and macro definitions too, which is quite handy, but I'm not going to do that today. You can also preview all the changes too, so we'll take a look at that first. Now, Eclipse gives us a list of all the files that will be changed, plus a before and after in the window below. I'll click OK, and Eclipse makes the changes. Now, Eclipse doesn't change the file names, and I want to keep my source code nice and tidy, so I'm going to change them manually. What Eclipse does do is update your include paths when you rename files, which is pretty cool. And that's a new feature because in the last version you had to do that manually. So I'll just right-click the header here and select rename and then change it to coord.h. Then I'll do the same with the CPP file. Right, so there are my two renamed files at the top, and if I do a build now, everything compiles exactly as it should. In fact, if we have a quick look in item.h, we can see that the include at the top of the file now says coord.h. It used to be pos.h, so Eclipse changed that when I renamed the file. Okay, one final change I'm going to make is to update the header guards, so I'll just change those from pos to coord. Then let's Control F6 back to main.cpp. We're going to add a new class as our final change, but first I just want to show you how to comment code out quickly. Eclipse has another keyboard shortcut, this time Control/, which will toggle a line to a comment and back again. So if I press Control/ here, it comments the line out and then the line below, and then I can revert them back to normal by pressing it again. Let's do our final bit of refactoring. Right, what we're going to do here is add a new subclass called movable item. Why are we going to do that? Because we have three classes here that inherit from the item class. We've got human, which inherits public item, gem, which inherits public item, and ghost, which inherits public item. However, human and ghost are movable objects and gem isn't. Since gems can't move around the maze, it would make more sense to subclass the movable part and derive ghost and human from it, and then to leave gem directly subclassed from item. This is polymorphism at work, and although it might seem like overkill on a small project like this, what you are doing by laying out your class hierarchy correctly from the beginning is making it easier to further develop and maintain your code in the future. This is also a really good way to work through programmatic changes and see the kind of issues that you'll be facing when you're developing your own programs. Knowing how to fix errors and move code around are skills that will aid you in the speed of your development. If you get lost or mess up your files, you can re-download the original files and start again. There really is no point in just watching what I'm doing. You become better at code and better at using tools such as Eclipse by doing. Doing beats watching, reading, thinking every single time. Okay, start by selecting File, New, Class. So class is down here, and then we get this dialog box pop up. Uncheck namespace, then give the class a name, movable item. We want this to be a subclass of item, so we can select the base class by clicking Add and searching for it. There's our item class, so click OK. Now, the eagle-eyed among you will notice that this dialog cuts off at the bottom. I actually can't access the bottom of this dialog on my laptop screen, and I can't scroll down in the dialog box. But if you're wondering what options are missing, it's the actual names of the header and CPP files, which are auto-generated from the class name. There's also an option right at the bottom to add a unit test, but we don't need that today. If you can't see these on your screen either, and you do want to access them, the only way I found is to alter your actual display resolution. However, the defaults are what we want, so luckily we can just click Finish. You can see the new movable item header and CPP files have been generated. What we're going to do now is update the ghost and human classes to derive from movable item instead of item, and then move the bits of code that relate to moving items out of the item class and into the movable item class. Okay, let's update the human class first and change the inheritance to movable item. Then we'll do the same for the ghost class. Oh, we also need to change the include at the top from item.h to movable item.h, so we'll do that and then change that in the human header as well. Next step is to go to the item header and cut the 4 methods that relate to moving objects around. Put these in the movable item header instead. Take them across to movable item and paste them under the public keyword. We also need to move the function declarations out of the item CPP file and paste those into the movable item CPP file. So let's highlight all 4, cut them, and then let's head over to movable item.cpp and paste them in. We need to update each method qualifier to be movable item. So highlight item and press Ctrl F, which is the find shortcut. We're going to do a straightforward find and replace. If you put a leading space in front of the word item, just to make sure it doesn't change substrings, then in the replace box do the same, type a leading space and then movable item. When you press replace all, you can see it tells you that 4 matches have been replaced, which is what we expect because we moved 4 methods from one class to another. If you suspect something has gone wrong at this point, you can reverse what you've done with edit, undo typing. You can see the movable items have changed back to items again, but I was happy with those changes, so I'll rerun the find replace to change them back, and then we can close this box. Use Ctrl F6 to navigate to the item.h file. We need to move the previous pos member variable, as only objects that move will ever have a previous position. Cut the variable and then take it across to the movable item header and paste it there under protected. Let's just add the protected keyword first and then paste in the variable. To complete the class changes, we need to update the constructors and destructors. So cut the delete call in item.cpp's destructor and move it to moveableitem.cpp. I'll just save the file and then take it over and paste it over this comment. And then remove the initialization of the previous pos variable from the constructor and put it in the new movable item constructor. Last of all, we need to add the x and y parameters to the constructor declaration and definition in movable item. So we need to pop an int x, int y into both of those. Now we've made all the class changes, let's run a build and see if we get any errors. Okay, so the first one we've got here, item is not a direct base of Ghost, that's fine. Click the error to go to the file in question. Update the base class initialization from item to movable item. If we build again, we have another error in the Ghost class where we're calling a base class function that is now part of movable item. So update the call on that line. Build again, and we have a second error like this. Change the base class call item to movable item and build again. Okay, now we have an error in the human class where we're initializing item instead of movable item. So update the constructor. This is what we just did in the Ghost class, and rebuild. And finally, our last error is in the movable item class itself because it needs to explicitly call the item constructor passing in the x and y parameters. So we need to add that here in the constructor. Okay, right, and then we'll do a final build. It should all build okay, and we should just check the program still runs as expected. Which it does. Fantastic. We've learned how to move around in our Eclipse projects. We've gotten some handy keyboard shortcuts under our belt. We've refactored a class method and refactored a class name. We'll take a break now before we move on to lesson 6, which covers the very serious subject of debugging.